Today we're learning about scientific notation. On our schedule is understanding what scientific notation is, how to convert standard numbers into scientific notation, and how to use a scientific calculator to make your job just a little bit easier. So let's think about it. The growth of a fingernail is measured in 0.000015 millimeters per hour. The sun's core temperature reaches 27 million degrees Fahrenheit. The distance from the Earth to the sun is about 93 million miles. Imagine having to do a math problem with numbers this large or this small. Would you want to compute math problems with those numbers? Probably not. So what can we do to make these numbers more manageable? We can use what's known as scientific notation. It's often used to express very large or very small numbers. It's also used to maintain the correct number of significant figures. A significant figure is any number that is necessary to the overall number. We can discuss that more in a moment. So essentially, all of that previous wording was just to say that scientific notation is a way of writing a number as a multiplication problem where the first number is greater than 0 but less than 10, and the second number is a power of 10. So this means that we can be dealing with numbers between 1 and 9.999, and then for the second number, we'll be using an exponent. For example, this is what scientific notation form looks like. Any number from 1 to 9.999 times 10 and an exponent. So the number 800, for example, can be written in scientific notation. We know that each of these zeros represents a power of 10. The ones place, the tens place, the hundreds place. Because the hundreds place has what we would consider a significant figure, a number other than 0, that 800 needs to express itself as 800, we must keep the 8. However, these zeros can be eliminated and phrased in a slightly different, more concise way. So 800 is simply us saying 8 times 10 times 10. And an even shorter way of saying that is 8 times 10 to the second. What about this number here, 2,531? Once again, we're already familiar with our numbers place, our place value. The 1 is in the ones place, the 3 is in the tens place, and the 5 is in the hundreds place, with the 2 in the thousands place. How do we write a number that doesn't have any zeros in it, meaning that every number is significant in scientific notation? Simply, you place a decimal point at the back of this number, because there is always a decimal point in a number, even if you can't see it, and you'll move that decimal point forward until it rests behind the first significant non-zero number. In this case, our first significant non-zero number is 2. So we'll move our imaginary decimal point 1, 2, 3 places, and now our number is 2.531. That means that we've moved our decimal point 3 tens places. which means that we have 2.531 times 10 to the third. That's a lot of numbers. That's kind of a wonky way of explaining it. How do we break that down even further? So again, before we do an example, 3 quick rules for scientific notation. You will place the decimal point so that there is only one non-zero number to the left, aka in front of the decimal point. Then you will count the number of decimal places that the decimal has moved. That number becomes your exponent. If the number that you started with, the original number, was less than 1, the exponent will be negative. If the number was greater than 1, the exponent will be positive. So let's go back to those numbers that we were working with at the very beginning when I asked you if you would even want to do a math problem with those. The growth of a fingernail is measured in 0.000015 millimeters per hour. Let's put 0.000015 into scientific notation. So here I have 0.000015. My first step is to move the decimal point until it is to the left of the first non-zero number. What does that look like? So I have 0, a decimal point, 0.000015. First, I need to locate the first non-zero number. That's the 1. Secondly, I'm going to move my decimal point until it is behind the first non-zero number. Moving it once doesn't accomplish that. Moving it twice doesn't accomplish that. Moving it again, and I still have not gotten it to the left of the first non-zero number. Once again, we still haven't done it. And if I place it here, now it is behind or to the left, it is to the left of the first non-zero number. Okay? So now we need to count up how many times we moved that decimal point to get it to that location. My decimal point was originally between the first and second zeros. So that means that I moved it 1, 2, 3, 4, 5 times. Okay? So I'm going to express that using a power of 10. I'll place an X or a multiplication symbol and then a 10. And then I'm going to use an exponential form. Because I moved my decimal point to the right 5 times, I'm going to place a 5 behind my 10 as the power or the exponent. All of these other zeros are now insignificant. I do not need them, and so I'll remove them. I still am not quite finished yet because 1.5 times 10 to a positive fifth power is a positive number, meaning that it'll be a very large number. But 0.000015 is a very small number. The original number was less than 1. And the rule says that if the original number is less than 1, I must make my exponent a negative number. So, when all is said and done, I'll be left with 1.5 times 10 to the negative fifth. If I were to multiply this back out, I would wind up with 0.0000015 because these two numbers are exactly the same. Let's try that again. The distance from the Earth to the Sun is about 93 million miles. So now let's put 93 million into scientific notation. First things first, if you can't see the decimal point, it is always behind the last number of the number, the last digit of the number. That made more sense. Okay? So, how then do I format 93 million in scientific notation? Well, we know that the first step is to move our decimal point until it is to the left of the first non-zero number. Okay? So I'm going to take my imaginary decimal point that now is a real decimal point, and I'm going to move it until it is directly next to the first non-zero number. Again, moving it once will not accomplish that. Twice, 3 times, 4 times, 5 times, six, 6 times, 7 is the lucky number. Now that I've placed my decimal point, I can place my multiplication symbol because I know that because I'm writing in scientific notation, I'll always be multiplying the number by a power of 10. So I can place my multiplication symbol and the 10. The next question is, just what is my exponent going to be? Again, that's simple. We're just going to count the number of times that we moved our decimal point. 1, 2, 3, 4, 5, 6, 7. So the exponent for this problem would be 7. So the next question is that a positive or a negative 7? Well, this number, when we originally started, was much greater than 1. That means that the exponent is positive. And so I do not need to add a negative sign. I can also get rid of all of these zeros because writing it as 9.3 times 10 to the 7th means that the zeros are all inside of that exponent. If I were to multiply this number out, I would wind up with 93 million. There are now 4 numbers on the screen that I would like you guys to practice converting into scientific notation. They are 61,500 kilograms, 0.00043 millimeters, 1 million protons, and 0.0345 grams. Remember the basic rules of scientific notation. You're going to place the decimal point behind the first non-zero number. Then you'll count the number of times that you moved the decimal point. That number will be your exponent. And lastly, if the number was greater than 1, then your exponent will be positive. And if the number was less than 1, then your exponent will be negative. You'll have 3 minutes to work those problems out. Your time begins now. Okay, now that we've had time to practice these numbers ourselves, let's see if your answers were correct. If you got these answers, then you were 100% correct. Now you're probably wondering if there isn't an easier way to do this. And the answer is, of course, yes. There are several ways to make your life a little bit easier when completing scientific notation calculations. The best of which, the easiest of which, is to use a scientific calculator. Now, although we may not be at school, every single last one of us has access to a scientific calculator if we have a smartphone. This video here will show you how to turn your iPhone into a scientific calculator. Great. So, in order to use your scientific calculator on your phone, all you'll do is flip your phone into landscape mode and boom, a calculator that is scientific instead of standard. Now, how do I use that to perform scientific notation? So, how do I use this new knowledge that my phone has a scientific calculator to perform scientific notation calculations? Simple. Once you flipped your phone into landscape mode, you will use the double E, the EE, both capitals, function as your exponent. The double E takes the place of you having to write out times 10. So instead of writing or typing into your calculator 6.15 times 10 to the fourth power, you would type in 6.15 EE 4, and that would give you 61,500. Go ahead and give it a try now. If you're like me and you happen to have an Android, your phone will also work as a scientific calculator. If you open your calculator app, I apologize, and flip your phone horizontally, you will reveal the scientific calculator. Unlike iPhones, however, we do not have the EE symbol. You will type. If you don't have a smartphone, but you do have access to an online function like Google search, you can search for online scientific calculator, and Google will provide you with one. What you can do here is utilize this in much the same way as you would a traditional scientific calculator. If we're going to use the same problem, we would type in 6.15, the multiplication symbol, a 10, and then we use this button here, x to the y power. It'll give you this little square box, and you'll place the proper number. And you should get the same answer, 61,500. So we can use online options to help us in place of standard scientific calculators during this time of remote learning. If you'd still like to have a more defined option for your learning processes, you can download several apps for your phone. The one that's most recommended for the iPhone is the Panacol Scientific Calculator. It looks like a traditional TI-84 or 83. If you have an Android, then the best app for now is the Real Calc Scientific Calculator. That app is available in the Play Store, and in much the same way as the Panacal Scientific Calculator is for the iPhone, the Real Calc looks like a scientific calculator. You can see here. Now that we've learned how to use scientific notation to convert numbers into from standard into scientific notation, let's talk about how we use those numbers in math problems or formulas once we've done that. Let's start with multiplication. The rule for multiplication, calculating with numbers written in scientific notation, is that you'll multiply the first factors, the numbers, and add the exponents. A sample problem here is multiply 3.2 times 10 to the negative 7 by 2.1 times 10 to the fifth. What we're going to do is multiply the first factors, the 3.2 and the 2.1, and we'll add the exponents, the negative 7 and the 5. So that will look like this. 3.2 times 2 to the first, blah. 3.2, I'm sorry. 3.2 times 2.1 will give us 6.72, and negative 7 plus a positive 5 will give us negative 2. We'll take that negative 2 and we'll use it in the exponent's place, and that will give us 10 to the negative 2. So our final answer will be 6.72 times 10 to the negative 2. Because we've multiplied our first factors, again, the standard numbers, and we've added our exponents. Now, I'll give you a few moments to try a problem by yourself. Try multiplying 14.6 times 10 to the 7th by 1.5 times 10 to the 4th. Alrighty. What you should come up with is 2.19 times 10 to the 12th power. You could also have written this as 21.9 times 7 to the 11th power, and that would also be acceptable. But the goal of scientific notation, remember, is to get the decimal point behind the first non-zero number. And that means that it should wind up as 2.19, not 21.9. That does also mean that your exponent here would change from an 11, despite 7 plus 4 equaling 11, to a 12, because you will have moved your decimal point one more time. Let's try some of these on our own. You can do them in your head, on paper, or you can use one of the scientific calculator options that I've shown you. I'll give you 5 minutes to complete that. All right, now let's go over your answers. Remember that the goal of scientific notation is to make the number as concise as possible. So although for this first problem you should have ended up with negative 6.525 times 10 to the negative ninth, it might be a little bit easier to say it as negative 6.5 times 10 to the negative ninth. Again, the goal is to be as concise as possible. How many answers did you get correct? And how many did you get wrong? Is there a particular reason why you might have gotten some of these wrong and others correct? Let's discuss division. When we're dividing numbers in scientific notation, you'll divide the first factor in the numerator by the first factor in the denominator. Then you'll subtract the exponent in the denominator from the exponent in the numerator. So I'm going to divide 6.4 times 10 to the sixth by 1.7 times 10 to the second. I'm going to divide 6.4 by 1.7. That will give me 3.76. And then I'm going to subtract 2 from 6. That will give me 4 or 10 to the fourth power. So my answer is 3.76 times 10 to the fourth. Now you try with this problem. Divide 2.4 times 10 to the 7th by 3.1 times 10 to the 14th. I'm sorry, the negative 7. 2.4 times 10 to the negative 7 by 3.1 times 10 to the 14th. You should have gotten 7.74 times 10 to the negative 22nd. Great. Now we're going to talk about one last thing before we close it out today, and that's rules for addition and subtraction. In order to add or subtract numbers written in scientific notation, they must be expressed with the same power of 10. So for example, I'm going to add 5.8 times 10 to the third and 2.16 times 10 to the fourth. Because these numbers, these exponents, don't have the same power of 10, I have to find a way to make them equal. That means that one of these numbers will have to have a decimal point moved. So 2.16, if I just move the decimal point 1 to the left, or to the right, I'm sorry, now I have 21.6, and that makes it to the power of 3. So I'll multiply both of these first factors, 5.8 and 21.6, by the same power, 10 to the third. Addition and subtraction of exponent or scientific notation simply means that you'll take 5.8 and you'll add it to 21.6. You should get 27.4. And because they now both share a factor of 3, it's still times 10 to the third. Your final answer, because again, the goal of scientific notation is to make a number as concise as possible, will be 2.74 times 10 to the fourth. Because in scientific notation, your decimal point should always reside behind the first non-zero number. You try by yourself. 8.32 times 10 to the negative 7, add 8.32 times 10 to the negative 7, and 1.2 times 10 to the negative 5. you should get 1.28 times 10 to the negative 5. Questions or concerns?